Okay, here we go. So this is lesson 23. We're dealing with parabolas. Okay, and that's what our lesson was on last time that you watched. So here's a parabola right here. And if the opening, I used to be a little bit confused on this, you guys, with the whole opens up. So if the opening is upward, then that's a parabola that opens up, and your vertex is right there, and that is a low point, okay? So you would say my vertex is 0, 0, and that is a minimum, okay? It's a low point, so it's a minimum. If the opening is down, then your vertex is a maximum. So right here, my vertex is 0, 0, and it's actually a maximum, okay? So very simple. Okay, so I think you've seen this before, and this is definitely a part of 1050. And so what I want you to do is I want you to just highlight that thing right there, and right in front of it, I want you to put a V, okay? So your vertex is negative b over 2a, comma, f of negative b over 2a. Now I know that you look at that yellow highlighted stuff, that notation, and I know it kind of probably freaks you out, but look what it's saying. It's really not that tough to understand, okay? So everybody look right here. So, I don't know why my pen is being weird lately. Okay, I have to write with my finger for a second, sorry. So anyway, the vertex is HK, and it's also that stuff up there, okay? So what I want you to write is, and I'm going to look like I'm in kindergarten because I'm writing with my finger, H equals, and it's negative B over 2A, okay? So you look at the equation, and you take the value of the A and B and C, and you plug it in, and you find the x coordinate of the vertex. And then what does this mean right here? What does f of negative b over 2a mean? Somebody in this room tell me. You're smart. Tell me what it means. It means take that negative b over 2a and do what to it? Come on, everyone should be able to tell me. You plug it back in. You plug it into the equation. Yes, okay. So let's do one if I can get my pen to work. It's so frustrating. Okay. Right here, determine the vertex or the turning point of the parabola and determine if it's a max or a min and find the axis of symmetry. Okay, so right underneath this, I want you to write down y equals a x to the second plus bx plus c. The a is in front of the x to the second. There's nothing there, so it's a 1. So everybody write a equals 1. The b is in front of the x, so it's a negative 4. And the c is the number that has no letter, and it's 1. Okay, so I want everybody to write my vertex is HK. The value of h equals negative b over 2a. b is a negative 4. So you're going to go negative 4 over 2 times a, which is a 1. So all I did is put in my values of b and my value of a. Okay, so I have a negative times a negative, that's a positive 4, over 1 times 2 is a 2, 4 over 2 is a 2. So now what I know, guys, is that the x coordinate of my vertex is a 2. How do I find the k, which is the y coordinate of the vertex? You take that 2 and you plug it into that equation. So everybody go y equals 2 to the second minus 4 times 2 plus 1. 2 to the second is a 4, a negative 4 times 2 is a negative 8, plus 1, 4 minus 8 is a negative 4, plus 1 is a negative 3, so I know my vertex is positive 2, negative 3. Okay, everybody in the room tell me, does this parabola open up or does it open down? I think that was on the last one. Up or down? It opens up. How do you know it opens up? Because in front of the x to second you have a positive. So if this is, let's just sketch a little picture right there. Okay, so there's your parabola that opens up. So is that vertex a max, everybody, or is it a min? It's a minimum, okay? The axis of symmetry, I didn't talk about this yet. It's always x equals h. So it's so easy, you just go x equals, and then it's just the x coordinate of the vertex, which is your value of h, which is a 2. So it's just x equals 2. You can't just put 2, you have to put x equals 2. It's an equation. Okay, let's do the next one. Find the vertex. So everybody go, my vertex is HK, H is negative B over 2A. If you forget the formula negative B over 2A, you're going to miss the problem. So you've got to make sure you know that, okay? You guys, my B is a 12 and my A is a 2. So this would be negative 12 over 2 times 2. That's a negative 12 over 4, which gives me a negative 3. So now I'm going to come down here, and I know that my x coordinate of the vertex is negative 3. How do I find the y? I go into that equation, and I put in a negative 3. So everybody go, y equals 2 parentheses, negative 3 in parentheses squared, plus 12 times negative 3 plus 1. Okay, grab your calculator. And let's just put the whole thing in our calculator. But you would have to write that down. Okay, so everybody go 2 parentheses, negative 3, close it off, x squared, plus 12 parentheses, negative 3, close it, plus 1, hit enter, and I get y equals negative 17. So I'm going to come right there, and I'm going to put that as the y coordinate of my vertex. Everybody in the room, does this parabola open up or down? Talk to me. It opens up, so that vertex is a minimum. The axis of symmetry is always x equals what on this problem, everybody? Negative 3. Yeah, that's it. Okay? Who says I'm good? I understand. Let's see. Hands up. Okay, great. All right. You guys already know this. To find the y-intercept, you're going to let x be a 0. So it's going to look like 0 comma c. To find the x-intercept, you're going to let y be a 0. Okay, so I'm going to let y be a 0. I just like to go some number comma 0. That's what the x-intercept is going to look like. Okay, so find the y-intercept. To find the y-intercept, you let x be a 0. So let's all go like this. Look, let's go 0 comma something. Okay, and then everybody go h of 0 is 3 times 0 squared plus 5 times 0 minus 1. I can tell that that gives me a negative 1, and I'm done. Okay, now I've always been super picky with work, but I don't think Weber State's going to make us show work on this. I think we can do this. Look, I know I'm going to let y be a 0. So this is going to become a 0, and this is going to become a 0 because they both have x's in it. So my answer is going to be right there. I think they're going to let us do that. Okay, so this one right here, find the y-intercept. So I'm going to let x be a 0. If x is a 0, this becomes a 0, and this becomes a 0, and my answer is what, everybody? 5. That's it. That's all we have to do. Okay? All right. A little bit of review. You guys already know this. The input is the x, and it's the independent variable. Remember, I goes to I. Okay? The y is the output, and that's the dependent variable. You guys, on what axis do you label the independent? Is that the horizontal or the vertical? Talk to me. Horizontal. So your independent goes here, and your dependent gets labeled over there. Okay? This is review 2. You guys know domain means all of the possible values. Okay, everybody listen to this, because I think now, at this point, you can understand this. Everybody look at this. Y equals 3x plus 1. Bless you. Okay? Take your pencil, draw an xy axis, and just sketch a graph something like that. Okay? If someone asked you, this is really so big to understand this right here, guys. Look. If someone asked you what the domain of that yellow highlighted line is, what would you say? Everybody tell me. All real numbers. Okay? So we're going to say domain is all real numbers. Now, what if they tell you this? What if they tell you that X stands for hours? Is your domain still all real numbers? Is it? Yes or no? Talk to me. Can you have negative hours? No. So the domain would be from 0 to infinity, including everything in between. Because you could, like if it was hours worked, you could work 0 hours, probably wouldn't be infinity. They would give you more details, like you can't work more than 40 hours in a week, let's say. So then the domain would be anywhere from 0 to 40. So the regular domain is what it looks like when you look at the equation, you look at the graph, and then the practical domain is when you think about what it stands for. I'm going to work anywhere between 0 and 40 hours. Okay? Who says I understand that? Raise your hand. Okay. When do you do this? People got confused on this. This is not the right answer. This means just 0 and just 40. This means anything in between 0 and 40, including 0 and 40. So this is not right, and this is right. Who says I understand? Raise your hand. Let's see. Okay, range. Range is the same way. Range is y. So if you look at that yellow graph, I know that my range is all real numbers. And then if they tell you that the y stands for pay, and let's say you make 10 bucks an hour, okay? So if you work 0 hours, you make $0, okay? So everybody right here, write down range stands for pay, and you make 10 bucks an hour. So guys, if you work 0 hours, you make $0. So the practical range would be from 0 to, if you work 40 hours, 40 times 10 is 400. So you're going to make anywhere from 0 to $400. Okay, who says I understand that? Let me see up high. Okay, great. Find the domain and range. Okay, everybody look up. We've done this. I know this is review, so just look right here. Domain is X. Start small. If I'm clear over here at a very small X, and I go up or down forever, am I ever going to touch that graph that keeps going that way? Talk to me. Yes, I am. Even if I go further, I just go further down. Look right here. Touches it here. Touches it. Touches it. Touches it. Touches it. What if I'm over here? Talk to me. Yes or no? Am I going to touch that value? Where? Down is exactly right. If I go further that way, I'm just going to go further down. Okay, so everybody in the room, tell me the domain. All real numbers, okay? And they didn't tell me how to write it, so all real numbers is great. Okay, range is Y, start low. If I'm down here, am I going to touch the graph? Yeah, I touch it twice. What if I go lower? Everybody in the room, talk to me. Yeah, it's going to hit it twice, just further out. No matter how low, it's just further out. What if I'm here? Touches it. Here, touches it. Touches it, touches it, touches it. Anything above that? No. What's that value? 3. So the range is, if I put this in interval form, it's going to be negative infinity, comma, you tell me, what do I put? 3, and how do I close my 3? With a bracket. Bracket, because it touches it, okay? If you look right here, honey, look, here's 3, and it actually touches it, so it'll be bracket, okay? Okay, here's question B, domain. Everybody in the room, just shout it. I know you know this. What's the domain? Everything, right? What's the range? Someone tell me the smallest Y value that actually touches that thing. A 3. How do I close that? With a bracket. And how high up does that thing go? Forever. Yep, to infinity. Okay, so that's easy. Okay, question 4. We're almost done. 4 and 5. Find the vertex, the axis of symmetry, find the stretch, graph it, blah, 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 blah. Okay, so I don't know if we've graphed a parent parabola. Everybody write y equals x to the second like that. If you have a 1 in front of the x to the second, then your stretch is 1, 1, 2, 4, with this corner dot being the vertex. So 1, 1, 2, 4. And then underneath that, I want you to write y equals ax squared. And if you have a number in front of that, like a stretch or a shrink, look what you do. You still go right 1 and right 2, but you take those up movements, which are 1 and 4, and you multiply them by whatever number's there. So 1 times a is a, and 4 times a is 4a. Okay, make sure you write that down. Okay, and then let's go through and do this. Okay, so find the vertex. So everybody write down on question A, my vertex is hk. H is negative b over 2a. B is the one that has the x to the first, so there isn't one. So that's just going to be negative 0 over 2 times a, which is a negative 1. Because if you have a 0 on the top, then that's going to be just a 0. Okay, so my vertex is 0, comma something. Now, if I put a 0 back into that equation, you guys, this negative x squared would become a 0, and then I would just have 0, 5. Okay? Axis of symmetry is going to be x equals 0. It's x equals whatever that number is right there. To find the y-intercept, you let x be a 0. Well, we already found that at 0, 5. Now, I'm not going to find the domain and range until I graph it. So let's graph this thing, okay? So don't go right or left, but go up 5 like that and make a dot. Now, this is a normal stretch, but this negative makes your parabola open where? Talk to me, everybody. Down, okay? So you're still going to go 1, 1, 2, 4, but you're going to go down. So everybody go right 1, down 1, left 1, down 1. Right 2, down 4, left 2, down 4. Does anybody know the next one? It would be 3, and then down, yeah, 3 squared is 9, yeah. So since I have room, I better do it because I want my parabola to be super accurate. So it looks like that, okay? And then the last thing we have to do is we have to find the domain and range, okay? So look at that parabola. Every person in this room, what is the domain? All real numbers, good. And the smallest y that touches my graph, well, it goes down forever, so it'd be negative infinity. What's the biggest y that touches my graph, everybody? 5. And tell me how to close my 5. With a bracket, okay? Who says I absolutely understand this? Raise your hand, let me see. Okay, good. Okay, right here. Find the vertex. So I'm going to say my vertex is HK. H is negative b over 2a. So I'm going to go negative. My b is a negative 4. So it's negative negative 4 over 2 times negative 2. That gives me a positive 4 on the top, a negative 4 on the bottom, and that gives me a negative 1. So I know that the x-coordinate of my vertex is negative 1. Every person in this room, tell me how to find the y-coordinate. Plug it in. Good. Everybody go h of negative 1. Make sure you write that down. That's the correct notation. H of negative 1 is negative 2 times negative 1 squared minus 4 times negative 1 minus 2. Let's just stick this in our calculator. So let's just go negative 2 parenthesis, negative 1 close it, x squared, minus 4 parenthesis, negative 1 close it, minus 2 enter, and I get a 0. Okay, so my vertex is negative 1, 0. Is the axis of symmetry negative 1? Is that correct? Is that how I write it? What do I put? X equals. If you don't have the x equals, you're going to lose it. Okay, you're going to lose the point. To find the y-intercept, I'm going to let x be a 0. You guys look at the original equation. If x is a 0, this goes away and this goes away. So what am I left with? That one that has no variables with it. So that would be negative 2. Okay, now let's graph it. Negative 1, 0, guys, is right here. Now, everybody in the room, does my parabola open up or does it open down? It opens down, right? Now everybody do this. Everybody go 1, 1, 2, 4. That's normal. This guy's not normal because of that 2. So I'm going to go 1 to the right and 2 to the right, but then I have to take those ups and stretch them 2 times more than what I was going to. So I go 1 times 2 is 2, and 4 times 2 is 8. Okay, pencil at the dot. Right 1 down 2, left 1 down 2, right 2 down 8. That puts me 1 off my grid. Same thing on the other side. Curve it in, and I'm done. Domain and range. By the way, everybody look right here for 2 seconds. See this red line I'm drawing right there? That's the axis of symmetry. Look forward for a sec, would you please? If I fold it across that red line, it's the same on the right as the left. What axis does that red line cross? X. Where does it cross it? Negative 1. That's why that's the axis of symmetry. Okay? Domain. Everybody in the room tell me what the domain is. All real numbers. The range is negative infinity to, tell me what it is. 0 with a what? With a bracket. Good. Okay? Okay, right here. Find your vertex. So we're going to go, my vertex is HK. H is negative b over 2a, which is negative 16 over 2 times 4. Negative negative 16 is 16. 4 times 2 is 8. 16 over 8 is a 2. So I know that my vertex is 2 comma something. Then I'm going to come right here and I'm going to go f of 2 is 4 times 2 squared minus 16 times 2 plus 10. Okay, grab your calculator. 4 parenthesis 2, close it, x squared, minus 16 parenthesis 2, close it, plus 10, hit enter, and I get a negative 6. So I know my vertex is positive 2, negative 6. I know the axis of symmetry is x equals 2. To find the y-intercept, I'm going to let x be a 0. Look at the equation, you guys. This goes away and this goes away, and I have a 10. So it's going to hit the y-axis at 0, 10. Okay, now I'm going to graph it. Everybody go right 2 and down 6. Make a dot. Now, this parabola opens up. Now, but the stretch is a 4. Everybody do this. Everybody go 1, 1, 2, 4. And then underneath that, I want you to go right 1, right 2. But you have to stretch it 2 times taller. 4 times taller. Is that 4? Yeah. So 1 times 4 is 4. 4 times 4 is 16. So that's really the stretch I'm taking. Okay? So from that dot, everybody go right 1, up 4, left 1 up 4, right 2 up 16. I don't think we're going to have enough room. I'm 1 off the grid, it looks like. So it looks like that. Curve it in. There's my graph. Okay? Okay, domain and range. Let's do that really quick. Everybody in the room, tell me the domain. All of you guys should be answering me. What is it? All real numbers. What's the lowest y value that touches the graph? Tell me. Negative 6. How do I close it? Bracket, and it goes up to, tell me, forever. Okay, good. All right. Question 5. Determine if it's linear, exponential, a log graph, or a quadratic. Okay, this was on the final last semester. Okay, first thing I want to tell you is if you have some that are not defined, if it tells you that there's no y value, which one do you think it is? Linear, exponential, log, or quadratic? What do you think? That there are x's that won't work. If you plug it into the equation, it won't give you a y. What do you think? Quadratic is a parabola. Every x, okay, let's draw these. Go like this. Do this. Quadratic. What does a log look like? Looks like this. And I want you to remember you have an asymptote right there. Exponential looks like this. Okay, and linear obviously looks like that. You guys, linear, the domain is all real numbers. Exponential, the domain is all real numbers. Quadratic, the domain is all real numbers. So the only one that has x's that won't work is a log graph. So you know this has got to be a logarithmic graph because there are x's that won't work. Okay, who says I understand what you're saying? Let me see. Okay, great. Let's look at this one. This one right here goes up by 1, up by 1, up by 1. Let's see what's happening here. To go from 1/4 to 1/2, I added a fourth. 1/4 plus 1/4 is 1/2. So then I say, is 1/4 plus 1 plus 1/2, does that give me 1? No. So I'm going to put right here, I know that this is not linear. Okay. I'm going to check if the other ones are linear. So let's see if any of these are linear. This one right here, look what's happening. We've got a pattern. Up 1, up 1, up 1. What's happening over here? Add 2. Negative 3 plus 2 is a negative 1. Negative 1 plus 2 is a 1. 1 plus 2 is a 3. This is linear. Okay. Now, I want to say one thing. Do this. Okay. Make this a 3. And make this a 5. Okay, just change it. So if that's the way it was, on the left, that would not be a plus 1, that would be a plus 2. And over here would not be a plus 2, it would be a plus 4. But the slope is still the same. Because if you put the change in y over the change in x, 2 over 1 is a 2. 2 over 1 is a 2. 4 over 2 is still a 2. So the slope is always consistent, so it's linear. Do I think that's going to happen? No, but just in case it does, I want you to be ready for that, okay? Okay, let's check if this guy's linear, okay? So everybody go plus 1, plus 1, plus 1. Right here you would go minus 1. Is 1 minus 1, 2? No, so I know this is not linear. So the only linear one is question C, okay? Now, question A could be a log graph, but you know what I'm going to check next? I'm going to actually check if there's something that I could multiply by 1/4 to get 1/2, okay? Let's do it this way. Let's come down here because it's easier to see this way. What do I multiply by 1 to get 2? That would be a 2. 1/4 times 2. Look at this. 1/4 times 2. Put a 1 underneath that. That's 2/4, which is the same thing as 1/2. So it is times 2. Look at this guy. Is 1/2 times 2, 1? Yes. So I'm multiplying by the same thing. So what's that guy? Everybody tell me that. It was on your quiz. Exponential. Yeah. What's your base, by the way? What would your base be raised to the x? Someone tell me that number. It's the number you're multiplying by. Yeah, be a 2. Okay, so let's see, and we don't know for sure, but this guy might be quadratic. Okay, so another thing you could do is you could just like graph it. Okay, so look, left 1, up 2, there's a point. 0, 1, there's a point. Positive 1, positive 2, and then positive 2, positive 5. Looks like that, okay? So if I drew a graph that connected those points, it would go like that. So what is it? Talk to me, guys. It's quadratic. Okay, so to find out if something is linear, okay, determine the slope, okay, which means find the difference in the x's, find the difference in the y's. If something is exponential, then the left-hand side is going to be added, and the right-hand side is going to be consistently multiplied. That's exponential, okay? For a log graph, if you can tell that it's not linear nor exponential, then graph it. Look at this. Positive 2, positive 1 is there. Positive 4, positive 2 is there. So do you see how it curves? So that's going to be a log graph, okay? So maybe to see if it's a log, I would just maybe plot some points. And then same thing over here with quadratic. I think I would probably just plot points. Okay, but this one right here on logarithmic, remember that you're going to have dashes in your y column. That's a symbolism. That's a, tells you it's probably going to be log. Okay, I think that's it. All right, we're done. Put everything down for a second, would you?